Alright, going along with the idea of properties of functions, we can talk about a property of symmetry, that functions can have various kinds of symmetry. Now, if you recall, we had symmetry of graphs, that a graph could have x-axis symmetry, meaning the top half was the mirror image of the bottom half. We could have y-axis symmetry, where the mirror here is the y-axis, that the left half is the mirror image of the right half, and we can have origin symmetry, where if we rotated everything around 180 degrees, everything looked the same. Well, we're going to relabel these ideas when we're talking about symmetry of functions. Now, to be a function, it can't have x-axis symmetry, because then it would fail the vertical line test, because whenever you have a part of the graph on top, you'd have to have on bottom, and that would immediately fail the vertical line test. So there is no analog of x-axis symmetry in symmetry of functions. For y-axis symmetry, we're going to call this even, that a function is even if it has y-axis symmetry. And we'll call a function odd if it has origin symmetry. So functions only have two types of symmetry: an even symmetry and an odd symmetry. Now, if you remember, for y-axis symmetry, for graphs, to test y-axis symmetry, what we would do is we would replace x with minus x and see if we got the same equation back. For the symmetry of a function, instead of y-axis symmetry, we just call it even symmetry. This is the same thing as saying that does f of x equal f of minus x. So again, it's a kind of, instead of x, we write minus x, and is f of minus x the same thing as the original? We're essentially doing the same exact thing, only we're using the function notation here. Now, for origin symmetry, we replaced x with minus x and y with minus y, and checked to see if we got, after simplifying, if we got the same equation as the original. For functions, origin symmetry is just called odd symmetry. And this is testing whether f of minus x is equal to minus f of x. Or if you will, this is the same thing as saying minus f of minus x, is that equal to f of x? Here's the original equation. Here, we're modifying the original equation by replacing x with minus x, and thinking of the function as being y. Oops, this should be minus y. Thinking of the function as y, instead of f, we're replacing it with minus f, or minus y. So again, we're doing the same thing when we're testing for symmetry of functions as we did for testing symmetry of graphs. but we're using the function notation. And I think you'll find that the function notation makes things a little bit easier to test. Let's take a look at an example just to demonstrate this. So I'm in section 1.4, and we'll look at number 26 on page, 107. So we're looking at the function g of x. We're defining g of x to be 3x to the fourth minus 5. And we're trying to test to see if g is even, odd, or has no symmetry, is neither even nor odd. Remember, just like graphs, a graph needn't have any of these three forms of symmetry. And in the same way, a function doesn't need to have any symmetry at all. But in this case, I think we'll find that it does have some symmetry. So, to test for symmetry, what you want to do is just replace x with minus x. Look at f of minus x. In this case, it's g, but whatever function, whatever letter your function has, just take it, and inside the parentheses, rather than x, replace it with minus x. So wherever we see x in the right-hand side, we're going to replace it with parentheses minus x. So this becomes 3 parentheses minus x to the fourth minus 5. So, how do we simplify this? And that's our next step, is just simplify. So, minus x to the fourth, that's minus x times minus x times minus x times minus x. So that's 4 negatives multiplied together. And when you multiply 4 negatives together, you get a positive. And I've got 4 x's multiplied together, which leave me with x to the fourth. So 3 times x to the fourth is just 3x to the fourth. And minus 5 stays as it is. So, is this the same thing as our original, as g of x? Yeah, it is. So, g of x is even. If what we have here is the same thing as minus g of x, minus g of x would be just negative 1 times all this, so it would be minus 3x to the fourth plus 5, and we don't have that here. This is not minus 3x to the fourth plus 5, it's something different. But if it was, this would say that g of x is odd, if this were true. But in this case, it's not. So, what we conclude is that g of x is even and not odd.